Virtualization, configure and verify data path virtualization technologies such as GRE and IPSec Tunneling. GRE stands for Generic Routing Encapsulation. It works with IP protocol number 47. It will encapsulate packets with a new header. This means that this protocol will help you have remote devices believing that they are connected to each other in a back-to-back manner. So it supports several payloads. So for instance, you can communicate two remote devices that are using IPv6 over an existing IPv4 network. GRE is known as an overlay protocol because it will use an existing IPv4 network or layer 3 network in order to create tunnels above it. When you're configuring it, you will be configuring virtual interfaces that are known as tunnels. These tunnels require you to provide a source IP address or source interface and a destination IP address. And the tunnel will come up as soon as the destination IP address appears in the routing table. These tunnels use keep alives to ensure bidirectional communication between the remote devices. You can choose not to use keep alives, but if you do that, you must make sure to use a routing protocol, because routing protocol hellos can serve the same purpose. Remember that GRE will steal 24 bytes from your MTU, and so you have to configure your MTU accordingly within your tunnel interfaces to reflect this. Otherwise, you will run into fragmentation problems or TCP maximum segment size problems. In order to configure GRE, use the interface tunnel command. You must supply a tunnel source and destination, configure an IP address, and optionally set the MTU, keep alive, and tunnel TTL. Use the command show interfaces tunnel to troubleshoot your tunnel. And this command will provide you with a lot of information. Look at it carefully. Before going into IPsec, let's comment about some security terminology. Data confidentiality means not sending data on the clear. This is achievable with encryption. There are several encryption algorithms. This is recommended that you should not use DES or triple DES anymore, but AES. Data integrity, and make sure that data was not changed when it is sent from source to destination. It is achievable with a hashing algorithm. There are a lot of hashing algorithms out there. It is recommended that you should not use MD5 but SHA. Authentication. Make sure that peers are really who they say they are. There are several types of authentications. The easier one is using pre-share keys. That means storing plain text pass keys on your devices. Otherwise, you must need certificates that are complex to deploy, because these are files that must be signed by a certificate authority device, and they expire, and they are very complex to work with. But they are much better than pre-share keys. Anti-replay protection means making sure that an attacker cannot send a repeated message to a destination. This is solved by the same hashing algorithms. These hashing algorithms will include a number or a sequence that changes with each packet, and these sequences have an expiration time. Key exchange or keying provide a way to exchange keys over an insecure channel. This is needed for encryption. These keys needs to change over time to make breaking the encryption algorithm a lot harder. The Diffie-Hellman groups are used for this. It is recommended not to use the Diffie-Hellman groups number 1, 2, 5, or 14. So what is IPsec? IPsec is a framework. It is a set of standards, a set of protocols, algorithms, and it is not really a protocol by itself, but it is rather a set of standards. IPsec provides you with two headers: the authentication headers, or AH, which uses IP protocol 51. It will not provide you with encryption, and it does not support NAT traversal. So that is why nobody uses AH too often. And the more often standard is the Encapsulation Security Payload, or ESP. It uses IP protocol 50. It will provide you with data integrity, authentication, anti-replay protection, encryption, supports non-traversal, and there are two types or two modes, tunnel mode and transport mode. In tunnel mode, it will add a new IP header. There are other terms that you will come across when talking about IPsec and VPNs. A security association is a relationship between two entities, and it consists of values such as destination address, a security parameter index, or SPI, which is an hexadecimal unique value, the transport set, security keys, and IPsec lifetime. So when two devices agree to establish a connection, an IPsec connection between them, they will have to create security associations, which are a set of information about this session. The encryption domain is a range of IP addresses that will be participating in an encrypted VPN. There are two types of VPN, generally speaking: policy-based VPNs and route-based VPN. Policy-based VPNs require an ACL that will be used to trigger the creation of the VPN, and only allowed traffic is permitted to use the VPN. For Cisco, if you have configured Cryptomaps, you have configured policy-based VPNs. Route-based VPNs support the exchange of dynamic routing information through the VPN tunnels. A transform set is a set of encryption algorithm and hashing algorithms that you choose, and you create transform sets like you will choose an item from a catalog, or like you choose food from a menu. There are several Cisco products. Site-to-site VPN is a standard to communicate remote networks using multi-vendor devices. Cisco also provides other VPN products such as DIM VPN, Get VPN, Flex VPN that uses EK version 2, and remote access VPN that is a solution for users that can install software in their laptops in order to communicate with a VPN concentrator. So let's focus this chapter on site-to-site IPsec. Internet Key Exchange, or IKE, is the mechanism for IPsec when it comes to site-to-site VPNs. IKE is also called the Internet Security Association and Key Management Protocol, or ISA-KMP. There are two versions of IKE. IKE version 1 that has been used for decades now, and IKE version 2, which is a more recent version. So IKE version 1 uses many messages to establish an IPsec session. It uses well-known hashing and encryption algorithms and protocols, and uses symmetric authentication, whereas IKE version 2 uses a lot less session messages, have more authentication methods. It supports asymmetric authentication, and supports next generation encryption. So now let's focus on Internet Key Exchange version 1. We are not going to talk a lot about IKE version 2. IKE version 1 consists of two phases. Phase 1 will provide control for the tunnel, providing key exchange, keep alive. This is known as the control plane phase. It will use UDP port 500. Whereas phase 2 is where the actual data gets transferred between devices. This is known as the data plane phase, and if you're using ESP, you will be using IP protocol 50. Now let's go into more detail about these phases. Phase 1 will negotiate a bidirectional security association. It exists in two modes. By default, it would use main mode, which consists of 6 steps, or you can choose to use aggressive mode that uses 3 steps. Aggressive mode is not as secure when it comes to authentication as main mode, but main mode would be slower. Phase 2 will negotiate two unidirectional security associations. It works with quick mode that adds 3 steps to the whole session, and you can optionally configure perfect forward secrecy. Now, regarding the configuration for phase 1, if you are configuring a Cisco device, all the commands that start with ISA KMP are related to phase 1. So every time you see in Cisco ISA KMP, think of phase 1. And when you see something that is any command that says IPSec, that is phase 2. So remember that ISA KMP is phase 1 and IPSec commands are phase 2. So how do you configure phase 1? Create policies. You can create at least, you should create at least one policy. Several policies are created to increase the chances of matching one of these policies or these combinations with a remote device. So first you create a policy. Second, optionally use aggressive mode. And finally, you establish the preshared key. If you're not using preshared key, in this moment you will have to install your certificates. In order to troubleshoot phase 1, use the command show crypto ISA KMP SA. Now, the configuration of phase 2 is only one command. Enter the command crypto IPSec transform set and choose among the menu what methods you want. In order to troubleshoot phase 2, use the command show crypto IPSec SA. Now, once you have configured phase 1 and phase 2, you have to choose your site-to-site configuration method. There are at least 2 types to configure this. The old way, which is a Cryptomap. This is the older way to configure site-to-site VPNs. It is a policy-based VPN. You need an access list. It does not support MPLS. It is complex to deploy. Access lists are prone to errors. Don't use this anymore. Let the beast die. And in order to configure this, you first have to define what is known as interesting traffic with an access list. This interest traffic will be the traffic that travels across an interface will be examined by the router, and if it sees interesting traffic there, it will set IPSec off. So first you have to configure an access list, then create a crypto map with whatever name you want for it, match the access list, match the transform set, establish to which peer this crypto map is aimed for, and apply the crypto map to a one interface. The other method is using an IPSec profile. This is a more recent way to configure IPSec. In order to use this, create the IPSec profile using the command crypto IPSec profile, establish the transform set, apply the profile to, for instance, a tunnel, and there is an optional command that enables what is known as VTI. If you use the VTI, even you're using tunnels, you will not using generic routing encapsulation at all, and it will be a pure IPSec transporting solution without the GRE. That's it.